Okay, Wildcats. Today we're at 10.3 Properties of Logarithms Assignment Tutorial. Question 1 of 16. Express the expression as a single logarithm and simplify. If necessary, round your answer to the nearest thousand. Use the product property of logarithms to simplify log base 9 of 12 plus log base 9 of 546.75. Okay, since it's plus, we multiply. So that's log base 9 of 12 times 546.75. At this point, we can just plug that into our calculator. So let's do that now. So on new document, add calculator. So control log base 9 of 12 times 546.75, and the answer is 4. Okay. All right, finish up question number 1. All right, question 2 of 16. Express the expression as a single logarithm and simplify. If necessary, round your answer to the nearest thousands. Use the quotient property of logarithms to simplify log base 2 of 22.4 minus log base 2 of 1.4. Now, when it subtract, you divide. So this is log base 2 of 22.4 divided by 1.4. Okay, so let's go and use our calculator. So control log base 2 of control divide 22.4 divided by 1.4. The answer is 4. All right, go ahead and finish up question 2. All right. Question 3 of 16. Express the expression as a single logarithm and simplify. If necessary, round your answer to the nearest thousands. Use the power property of logarithm to simplify log 4/5 of 0.4096 to the third power. So the 3 comes to the front, so that's 3 times log of 4/5 of 0.4096. And we can just plug that into our calculator. So 3 times log base control divide 4/5 of 0.4096. The answer is 12. Go ahead and finish up question 3. All right. Question 416. Express the expression as a single logarithm and simplify. If necessary, round your answer to the nearest thousands. Use the power property of logarithms to simplify log base 16 of 16 of 35. So the 35 comes to the front. So 35 times log base 16 of 16. Well, this is just 1, so that's equal to 35 times 1, which equals 35. Go ahead and finish up question 4. Okay, question 5 of 16. Express the expression as a single logarithm and simplify. If necessary, round your answer to the nearest thousands. Use the definition of logarithms to simplify log base 5 of x plus 3 plus log base 9 of 729 to the fourth power. So the x plus 3 comes to the front, so that's x plus 3 times log base 5 of 5 plus the 4 comes to the front, times log base 9 of 729. Okay, well, this is just 1, so that's x plus 3 times 1 plus, let's go ahead and put that in our calculator. So 4 times control log base 9 of 729. Okay, and that equals 12. So 1 times this is just x plus 3. Plus 12. Well, 3 plus 12 is 15, so that equals x plus 15. All right, go and finish up question 5. All of 16. All right. Question 6 of 16. Express the expression as a single logarithm and simplify. If necessary, round your answer to the nearest thousand. Use the quotient property of logarithms to simplify log of 5 of 50 minus log base 5 of 2. So first off, the x comes to the front, so that's x times log of log base 5 of 50 minus log base 5 of 2. So that's x times, let's go ahead and put that in our calculator. So that's control log. If there's not a base, we assume it's 10 of control log base 5 of 50 plus control log base 5 of 2. And that equals 0.45. They want to the nearest thousand, so 0.457. Okay, so then that's just 0.457 times x. All right, go ahead and finish up question 6 of 16. All right. Question 7 of 16. Express the expression as a single logarithm and simplify. If necessary, round your answer to the nearest thousands. Okay, so first off, we bring the 4 to the front, so that's 4 times log base x plus 9. We're going to factor that as 2 parentheses. We know x and x makes x squared. Now we need to find all the numbers that multiply to give you 1 and combine to be 18. Okay, and we can actually use our calculator for this. We're going to go on, new document, no, add list in spreadsheets. So let's call this x, let's call this y. Okay, now the y we want to be 81 divided by x. We're going to make that a variable reference. Okay, and then we want to add the x plus y. And again, we're going to make a variable reference for that and a variable reference for this. So let's just start with 1. Okay, that works, but they don't add up to be 18. So let's try 2. Nope. 3. Nope. 4. Nope. 5. Nope. 6. 7. Nope. 8. Nope. 9. That works because they multiply to give you 81 and combine to be 18. So our factors are x plus 9, x plus 9. Well, x plus 9 times x plus 9 is x plus 9 squared. So this is 4 times log base x plus 9 of x plus 9 squared. Well, the 2 goes in the front, so that's 4 times 2 times log base x plus 9 of x plus 9. Well, 4 times 2 is 8 times, that's 1, so it equals 8. All right, go ahead and finish up question 7 of 16. All right, question 8 of 16. Express the expression as a single logarithm and simplify. If necessary, round your answer to the nearest thousands. Use the product property of logarithms to simplify log base 2 of 5 plus log base 2 of 8 minus log base 2 of 1.25. I honestly think this one is just easier just to put in a calculator, so let's do that. So control log base 2 of 5 plus control log base 2 of 8 minus control log base 2 of 1.25, and that all equals 5. Okay, go ahead and finish up question 8 of 16. All right, question 9. I recommend using the step-by-step feature to answer that question. Question 10, again, I recommend using the step-by-step feature. Question 11, again, use the step-by-step feature. Question 12, use the step-by-step feature. Question 13, use the step-by-step feature. And question 16. Now, I actually recommend using your example 2 from your journal page. That will help you. I will just kind of slide through this paper and read through it, but again, you could go back to your example 2. So prove the quotient property of logarithms, justify each step of your proof. Step 1. Let x equals log base b of m and y equals log base b of n. Therefore, m equals b to the x and n equals b to the y by the definition of a logarithm. Step 2. Substitute m equals b to the x and n equals b to the y to log base b of m divided by n. Log base b of m divided by m equals log base b of b to the x divided by b to the y. Step 3. Let log base b of b to the x divided by b to the y equals log base b of b to the x minus y because the quotient of powers property of exponents. Step 4. Log base b of b to the x minus y equals x minus y times log base b of b equals x minus y times 1, which equals x minus y. Since x equals log base b of m and y equals log base b of n, therefore x minus y equals log base b of m minus log base b of n. All right. Now, question 15 to 16. Again, you can use example 3 from your journal page to help you with this, but I'll go through it in the video again. Prove the change of base property of logarithms and justify each step of your proof. Step 1. Let x equals log base c of a. Therefore, a equals c to the x by the definition of a logarithm. Step 2. Start with a equals c to the x and take the log of both sides. So a equals c to the x, take log base b of both sides. So in step 3, log base b of a equals x times log base b of c because of the power properties of logarithms. Step 4. Divide both sides of log base b of a equals x log base b of c by log base b of c. And when you do that, this divides and becomes 1, and you're left with just x equals log base b of a divided by log base b of c. Since x equals log base c of a, therefore log base c of a equals log b of a divided by log base b of c. All right, go ahead and finish up question 15 to 16. All right, question 16 of 16. Again, this is can be used example 4 from your notes and examples. Complete the explanation of how it defined the relationship between log base b of a and log 1 divided by b of a. Step 1. Convert the expression of log base b of a using the same base. Log of a equals log of a divided by log of b. Step 2. Convert the expression log of 1 divided by b of a using the same base. So log 1 divided by b of a equals log of a divided by log of 1 divided by b. Step 3. Simplify the expression log of a divided by log of 1 divided by b. And when you do that, log of 1 divided by b is equal to b to the negative 1. So then the negative 1 comes to the front, so log of a divided by negative 1 times log of b. Then negative 1 can come to the front and multiplied by log of a divided by log of b. So in step 4, so log 1 of b, 1 divided by b of a is the opposite of log of b of a. All right, go and finish up your assignment and have a wonderful Wildcat day.